empty bottle of Coke, a punctured bottle cap, a serving bowl, and an old empty jar of honey. Is this a pile of junk or a clock? My name is Jordan D'Amico, and this shabby little thing is my homemade water clock, or clepsydra as the Greeks knew it. This is a thousands of year old device and concept dating back all the way to the ruins of ancient Egypt as we know it. This clock story is a story of not just accuracy, but inaccuracy. And today, I will be going through all the trials and tribulations, falsehoods and truths that I had to go through to make this clock what it is now, and perhaps the steps I could have taken to improve it. I actually ended up going through a couple of different designs before finally choosing the one I ended up with, but it all started with an empty Coke bottle that I took the label and cap off of, took a thing of thumbtack and struck a little bit of a hole in the cap so the water had a place to go through at a small rate. I then screwed the cap back on the bottle and began to cut the bottom of the bottle so that the water had a place to go through when I was filling it. My original design had me puncturing a small hole near the top of the bottle so I could attach the bottle to a hook through that hole. I soon realized that was a terrible idea since all the water would go through that big hole instead of the small hole I wanted it to. So I started over and attached my bottle to a phone tripod and then set everything else at the foot of it. After taping the bottle to the tripod, I then started filling the bottle with water and watched it trickle down to the jar below. I eventually just scrapped the tripod altogether due to stability issues, and then I used my phone's timer to see how tall the water would get on the jar in relation to certain limits of time, like 1 minute, 2 minutes, 3 minutes, etc., and eventually found out that 15 minutes was the maximum amount of time my water clock could track in a single cycle. Now let's put this clock to the test. I'm going to be using a phone timer as a secondary timer to check the accuracy, and I'm going to see how long it takes me to make a cup of tea using my water clock and cross-referencing with my actual timer. Let's see. All right, we got 14 minutes and 15 seconds on this end. Let's see how my water clock did. Ooh, look at that. Just under 14 minutes, so just in between 13 and 14. So slightly accurate, but what happened there? The Greek intellectual Ctesibius pointed out that water pressure plays a huge part in this. As the water gets less and less, the water pressure gets lower and lower, so the rate of flow gets slower as the cycle goes to a close. If I were to improve my water clock in the future, I would take Ctesibius' advice and have a constant flow of water going through the bottle so that the water pressure does not change throughout it, so you would have an unhindered accuracy. But overall, I'm proud of my water clock because it proved to be a wonderful learning opportunity to learn about water pressure and its effects on telling time.